Hello, in today's daily lead code challenge, the question is find the closest node to given two nodes. So here we are given with a directed graph of n nodes, which are numbered from 0 to n minus 1, and where each node had at most one outgoing edge, right? And the graph is represented as a zero indexed array edges of size n, indicating there is a directed edge between node I and node edges I, right? If there exists no any outgoing edge, it will be represented as minus 1, right? And we are also given with node 1 and node 2. So what we have to do is we have to return the index of node that can be reached from node 1 and node 2, and the maximum distance between that to reach that node from node 1 and node 2 should be minimized. And if there exists multiple answer, we have to return the smallest index, and if there is no possible answer, we have to return minus 1, right? So here we can see that from node 0 to 1 we can reach to index number 2 with one step, and index number 3 to two steps, right? So our answer would be 3. Answer would be 2 here. And in the following example we can see that the answer would be 2 here. Okay, so size of a node, size of the nodes of the graph could go up to 10 to the power 5. So to find the minimum distance to each node from a source node, we can use a multi-source BFS here, and find the and store that path length to node 1 and node 2 in two arrays of distances, right? And we will calculate that maximum distance between, if it is reachable, so the maximum distance would be not infinity, right? And if it is minimized, so we will store that index as our answer, right? So it is a multi-source BFS question in which we have to store the distances and also find the maximum distance between them which is minimized, right? So let's code this question in C++ or Java, and try to submit this question. So let's jump on to the coding. So what I have done here is that I have found the distance 1 and distance 2 via the BFS from node 1 and node 2 to the edges which are given there. So I am finding the minimum distance which is being ensured by the VFS, and I will initialize the answer which is being distance in this case to the maximum, and infinity in this infinity here, and the index number as minus 1. So whenever I find a distance which is been less than the infinity and less than the current found output, so what I will do is I will have my answer as max of both that distances, and mark that index as the like resulting index which is been like the maximum distance to reach that point is minimized, right? So this is that. And I have also done some BFS which is basic BFS. I am marking that node as visited whenever I like pop that out of the queue, and also the distance t is the label at which I am inserting that node, and removing that node out of from the queue, right? So that ensure the minimum number of moves to reach there, minimum number of edges to reach there. I hope you are getting the pros. If you have any doubt, you can comment down below in the question. So this is the C++ solution for today's question. So let's try to submit this. So it got accepted in C++. Let's try to do this question in Java. So that will be useful for Java guys who are out there. So let's code it in Java. So in the Java approach, what I have done is that I have also made a graph which it can also be done in C++, but I have escaped there. So do that directly. So you can also apply this approach in C++ as well, where I am discarding all of the minus one, my all of the nodes, all of the neighbors of the nodes which are minus one inserted there. So it will be directly working as a graph, which is a adjacency list in this case. All of the implementation is same as the C++. So this is the solution for today's daily lead code challenge in Java. So let's try to submit this. So it got accepted in Java as well. So this is the solution for today's daily lead code challenge. So thank you for watching.